So this video is going to go over part 3 of the mini mole lab. So I'm going to go through exactly what kind of data you're going to take and how to do the calculation. So I am using this bag. It has a Roman numeral 3, so that means it's part 3 of the mini mole. This is bag number 1, and what you're going to see differently on these bags is this is called a formula unit. So it's going to be 3.35 times 10 to the 23rd if you have the black group that you're working with. The bag itself has a mass of 6.43 grams. So I'm going to write that all on a piece of paper here. So bag number 1. So the formula units is 3.35 times 10 to the 23rd. And the mass of the bag itself is 6.43 grams. So you're going to take this bag and go to your balance and mass the whole thing. So you're going to have the mass of the bag and the compound. So what's different about this part versus the other parts that you have done previously is you're going to have to do all of the bags, and these are compounds that you have in there, compounds, and you're going to try to figure out which compound you have. So if I took the mass of it, it is 39.03 grams of the bag and the compound. So when I subtract those two numbers, I should get the mass of the compound is going to be 33.6. No, 32.6. 32.6. All right, so what you're going to be asked to do is as follows. So from the lab itself, you're going to be given 5 different bags, and each contain a white powder. So each one of the bags are either sodium chloride, potassium sulfate, sodium carbonate, magnesium carbonate, or calcium acetate. So you're going to have to figure out which one you have. So what you're going to be doing is a series of calculations from that data. And from there, you are going to find which substance you have. Okay, so let's go back to what I was creating here. So I need to figure out what the molar mass is of this compound. And molar mass is grams per mole. Okay, grams per mole. So what I can do is I have formula units. So formula units can give me moles, and I have the mass already. Okay, so the mass is easy. That's just going to be the mass of the compound. But the moles is going to require one step calculation. So write down 3.35 times 10 to the 23rd formula units is how many moles if I have Avogadro's number, 6.02 times 10 to the 23rd formula units for every 1 mole. Okay, 6.02 times 10 to the 23rd. So I cross multiply, and I essentially take 3.35 times 10 to the 23rd and divide it by 6.02 times 10 to the 23rd, and I get my number of moles. So I am going to do the calculation in the calculator just so you can see it. Again, you're using the double E button on your calculator to kind of help you do the calculation correctly. If you don't use the double E button, you just need to remember to put everything in parentheses, otherwise division will not work. So I'm going to take 3.35, so 3.35. I'm going to hit second function E so that the E pops up in my screen, and I take 23. I hit the division key, and then this is where I type in Avogadro's number, 6.02, second function E, 23. So the E just gives you the power of 10, and when I hit the enter key, I get my answer. And again, I have 3 sig figs here, so it's going to be 0.556. So 0.556 is going to be my moles, going to be my mole. Okay, so last step here is to essentially find my molar mass of this compound. So I know 32.6 grams is the mass of the compound, and my moles is 0.556 moles. I want to know if the grams per 1 mole. Okay, so essentially what I'm doing is dividing these two numbers to get it to 1. So I take 32 times 1, 0.556 times x. So essentially I'm taking 32.6 dividing it by 0.556. So my x comes out to be 58.6 grams per mole. So back to the lab itself. That molar mass has to be either sodium chloride's molar mass, potassium sulfate, sodium carbonate, magnesium carbonate, or calcium acetate. So for each one of these, you need to write their formulas and calculate their molar masses. If their molar mass adds up to 58.6, like we did in bag 1, then you know it's which of these compounds. So each of the 5 bags, you're going to do the same calculation with those numbers, okay, the numbers that you have, and then you're going to determine which one of these you have. So my suggestion is to make sure that you write the formulas correctly, because if your molar masses don't match up, it's probably because your molar masses are adding to the wrong thing. So again, sodium chloride's easy, but when you get to potassium sulfate, can you write the proper formula? So again, that is going to be what you do in part 3. So good luck. And that's all I have.